Welcome to our second unit with quadratics. We've had our introduction to quadratics and what a parabola looks like when we graph it. Boy, I miss your faces and working directly with you guys, but unfortunately, this is the way it is, and here we go. Today we're going to work with polynomials. So some of these things you already know from previous math in terms of adding and subtracting polynomials, collecting the like terms, some multiplication, but we're going to extend those skills this year. So let's start with reviewing some of the vocabulary you should know. A term is just a number or a variable or the product, which is multiplication of numbers and or variables. All right, so for example, we could have 7. 7 is a term. Or x. X is a term. You could have 7 times x or 7x. That's a term. You could have negative 2x squared. That's a term. You could have a squared b. That's a term. So these things, there's no add or subtracts in betweens. I do have a negative in front of a 2 here, but that's not a subtract, it's just a negative. You could even have something like negative 3x over 2y. That actually, when we say product, that really is the product of minus 3x times 1 over 2y. So that's also a term. So product, you could also have divide with it. As long as you don't have an add or subtract in it, it's just a single term. Now when we talk about the degree of the term, we're going to look at the variable part of the term. And when we look at the variable part, we're looking at the sum of the exponents on the variables. So a degree is just the sum of the exponents on the variables of a term. So for example, if I have 7, there are no variables on that. Let me just get my tool out here. Example of 7. There are no variables. This is a degree of 0 because there are no terms. Variables. It is one term, but there's no variable in there, so its exponent would have to be a 0. If I have the x is a degree of 1. If I have, I'm just going to go to 7x now, that is also a degree of 1 because I'm only looking at the variable part. And when there's no exponent written, remember there's an imaginary number 1 as an exponent there. If I have a minus 2x squared, the degree on that is a 2. And it's not because there's a 2 in the front, it's because the 2 is the exponent. If I have my a squared b, that's a degree of 3. And the reason it's a degree of 3 is because I have a 2 here, but there's also a 1 here. And when I take the sum of 2 and 1, I get a 3 out of that. If I had, let me see, I'm going to do another one here. Let's just do one more. If I had 9x cubed y to the 5, that would be a degree 8 because I would be adding the 3 and the 5 together. Let's just fix my printing here. Degree 8. Okay, so that's the degree of a term here. The 3 and the 5 added together gives us an 8. All right, polynomials are when you take these terms and you just add or subtract them together. So polynomials, we have things like monomials, binomials, trinomials we would have talked about in grade 9. Polynomial is just a generic word to describe the sum or subtraction of a various number of terms. So I have some examples here. My first polynomial is just 5x squared y. There's no plus or minus in this. This is just one term, and when we have one term, that's called a monomial. So a specific polynomial with just one term in it is called a monomial. Okay, there's one term. This has a degree of 3, one term degree of 3. My second example, there are actually 2 terms here because we do have that plus sign in between. So we've got the 9x, but then we're adding 3y. So there's 2 terms there. 2 terms is called a binomial. It's a specific type of polynomial with just 2 terms. And then my last example here has a 4x squared a minus 7y, and a plus 8x. So you can see the subtract and the add separate our terms out. 3 terms have a specific name called a trinomial. So in general, they're all called polynomials, and if we went into 4 terms, we just call them polynomials. 5 terms, polynomials. We just have specific names for 1, 2, and 3 terms on that. Now, for the degree of a polynomial, you're going to look at the degree of the individual terms, and then whichever one is the highest wins. That's the degree for your polynomial. So here I have an example of 9x cubed y minus 7x to the 5y cubed plus 2xy to the 6. So what we do is we look at the individual terms and get the degree of each of those. So this very first term here, I'm adding my exponents together. That's a degree of 4. I'm just going to put a 4 underneath. It's a degree of 4. My second term has a 5 and a 3. If I add those together, that's a degree of 8. My third term has a 1 here and a 6 here. That's a degree of 7. So overall, the biggest number is 8. Overall, this polynomial has a degree of 8. All right, a quadratic is a specific type of polynomial, a polynomial expression with a degree of 2. The highest exponent on the variable is a 2. So in our last unit, we were focusing on these polynomial expressions, or in fact the polynomial relationships, the y equals, and we found these were the ones that gave us the nice U-shaped curve when we graphed those. So for example, we had things like y equals. I'm going to leave off the y equals part because I don't want the actual graph. I just want the expression, the algebraic part of this. So we get 3x squared minus 8x plus 5. That, for example, is a degree 2. And that's because this first term has a 2. This second term has a degree of 1. This last term has a degree of 0. So overall, the largest one wins. It's a degree of 2. Another possibility, let me get the right color of pen here. Another possibility is we could have something that looks like this, x and then bracket 2x minus 5. Now, right now, that does not look like a degree of 2. Let me just change this 2 to a 3 there. But if we were to expand and simplify this, if we multiply, because really that x in front of that bracket means to multiply, that x is going to be distributed, that's the distributive property, distributed through the bracket. It's going to multiply both terms in the brackets. So I really have a monomial times a binomial. The x times 3x would be 3x to the exponent of 2, because x times x gives us an x squared, and then minus an x times 5 is 5x. So you can see that that does produce a degree of 2. All right, we're going to quickly review how to add and subtract some polynomials here. All right, so adding and subtracting polynomials, you can only combine like terms, only terms that have identical variable parts to it. So only terms that have identical variable parts, and we're going to discuss that with some of these examples. Those are the only ones that can be combined. So if you look at 3a plus 5b, so 3a plus 5b minus 8a plus 6b, the 3a and the minus 8a can go together because those variable parts are both just a's. So 3 take away 8 would equal negative 5. So you're just adding or subtracting your coefficients here. So negative 5 a's. And then we're going to look at the b's. We have plus 5b, and we're going to add 6 more b's. Altogether, that would give us 11 b's. All right, next, I have a 3x squared, and I also have a minus 9x squared. So the sign in front goes with that 9. So I have 3, but I'm taking 9 away. That's going to give us minus 6x squared. And then we have a minus 6x and a plus 8x and a minus 4x. Those are all just x to the ones. They can go together. A minus 6x plus 8x would be 2x's. 2x's take away 4x's would be minus 2x. All right, this last one's a doozy. You really have to be careful with this one. There's all kinds of A's and B's here, but we have to make sure that they're like terms. I have 6ab squared, so I want to find anything else that has an a to a 1 and a b squared in it. So this has an a to the 2. Right away, the second one doesn't work. Same with the third has an a squared. Oh, but the fourth one has an ab squared in it. Looking the fifth one, no, and the sixth one, no. Okay, so those two I've underlined in green can go together. 6 take away 4 would be 2. That's going to be an ab squared. Now I'm looking at the a squared b. A squared b, any more a squared b's? No. So there's no other a squared b's to go together. So I'm just going to leave that as a minus 9a squared b. Now I have an a squared b squared. A squared b squared, I have 2a squared b squareds, but I also have a plus 5a squared b squared. Altogether that's 7a squared b squareds. And then I've got this lonely little 7ab without any like terms to go with it. So just be careful, make sure your exponents match. If I also had, let's say I also had a plus 4ba. If I had a plus 4ba, then that would make the 7ab and the 4ba actually like terms. So the order that the variables are multiplied in does not matter. It's just that their exponents have to be the same. So just keep that in mind. I should have put that into my example to remind you that that does work, that those are like terms. All right, we're going to move into expand and simplify. And this is that distributive property we were talking about earlier. The 3 is in front of this bracket here. We're going to multiply that 3 with the a and the 3 with the 4. When we multiply those together, we're going to get a 3 times a, or 3a, and then plus, because we have a plus here, multiplying a plus, that's not written, but it's assumed to be there. 3 times 4 is a 12. And that's done. There's no like terms to put together. You can't put the a with the constant 12. So expand and simplify just means multiply and collect like terms if you can. All right, our next example, we've got the 3x. This is a monomial. It's multiplying this binomial. It's going to distribute through that bracket. 3 times the 2 gives us a 6. 3 times 2 is a 6. X times x would be an x squared. And then the 3x multiplies the minus 5y. A positive 3 times a minus 5 would be a minus 15. X times y is just xy. And I'm going to continue this lesson on our next video.